Okay, so in this one on your notes, DCAB, I would call that a face of your polyhedron. All right, I also mentioned to have edges. Edges. Let's see, I'll pick edge CG up here. Okay, CG right here, that's referred to as an edge. And then connecting those edges are what we call vertices. I'll go vertice H. Okay, H is a vertice. All right, so all these polyhedrons have faces, edges, and vertices. First thing I want to do with you today in your notes is, can you count how many? Okay, can you count how many? And before we count, though, I do want to start giving names to all these polyhedrons so you can become more and more familiar with these names. Number one, this is called a cube. All right, called a cube. So can you take your time, because I know it's very easy at the start of this to double count something. Count how many faces, edges, and vertices this cube has right now. How many faces, edges, and vertices the cube has. Take your time, because again, it's easy to skip over one or count one twice. All right, I won't call anybody for this one just to make sure you guys got this down, but I will for the next two here. There should be 6 faces, top, bottom, left, right, front, back. 12 edges, you counted, along with 8 vertices. Okay, 6, 12, and 8. Look good? All right, next one here. I don't know if you guys know what the name of this one is. We're going to study it tomorrow. This is a pyramid. Polyhedron called a pyramid. All right, so go ahead again, find the number of faces, edges, vertices. The bottom counts too. The floor there of the pyramid counts as a face. I'm sure I'm going to have to skip over a bunch of numbers, but I'm okay with that because I want to make sure we've got this. Lennon, how many faces do you have? 5. Did you count how many edges? 8. Good work. And then vertices? 5. Good job. Good job. All right, last one here to count the faces and edges and vertices. This is called a prism, which we're going to start talking about today. Not only is it a prism, let's get more specific, it's a triangular prism. I'll tell you why it's called the triangular prism when we start looking at them later. Triangular prism. So again, faces, edges, vertices. Alrighty, when you have it here, let's get number of faces up. Number of faces. Juliana, go ahead. Number of faces. 5. Yep. Edges. 9 and vertices. 6. Good work. I think it was sometime in the 1700s. One of the mathematicians he noticed the pattern. Okay, he noticed the pattern, and I want to give you that pattern. So going forward, when you do these types of problems, you can check to see if you do have the correct number of all 3. Again, it's very easy to double count one or forget to count one. So here's what he found. He found out that when you add the number of faces and vertices together, and this works for all 3 of ours here, when you add the number of faces and vertices, and always always subtract 2 from that number, you will always come up with the number of edges. So if you look at our 3 examples here, look, 6 plus 8, subtract 2 from it. Yeah, I get 12. 5 plus 5 minus 2, I get 8. 5 plus 6 minus 2, I get 9. So there's a little check to see if you got the correct number of all 3. Anything you'd like to ask, comment about faces, edges, vertices before we start cutting our polyhedrons here? All right, so here's what we're going to do next. We are going to take our polyhedrons and slice them. All different ways we're going to slice them. And when I slice it, I'm going to hold it up to you. And what I'm holding up to you is a shape that's called the cross section. Okay, that is called a cross section. Me doing that doesn't do any justice. So let me show you a little virtual example here. Let me start with a cylinder. Let me start with a cylinder up here. All right, everyone see I'm cutting it horizontally up here. And if I hold it up to you, what's it going to be? A circle. So in this case, the cross section would be a circle. Now, is it going to be a circle every time? No, it depends on how I cut it. Watch. It will not always be a circle. Sorry. Come on, what are you doing? What's the deal here? There we go. Okay, take a look. I cut it vertically. It's not a circle anymore, is it? It's a rectangle. So when you're dealing with the cross sections of figures, you have to understand where you're cutting it because that could change the shape of the cross section. Okay, so again, I cut it vertically. It ends up being a rectangle. But hey, you cut it horizontally. What did we see? It ends up being a circle. All right, so a quick couple questions about that. All right, which one of these figures has the same cross section of a sphere as a sphere? So if you flip over your notes there, as a sphere. Well, first, what does the cross section of a sphere look like? I hate to break it to you, but it won't matter how we cut a sphere. Everyone see I'm cutting it horizontally. Now watch, I'll cut it any way you want. What's the cross section always going to be? A circle. So what I'm asking in this problem is, which one of these can I cut in any way and also get a circle back? So take a look, think in your mind here. Which one can I cut any direction and I will get a circle back as the cross section? So we can also show it virtually up here too if we need to. Up here, let's keep it going. We'll keep it. ET, which one do you think?
2.
2, yeah. A cone, if you go it horizontally. Again, I don't mind showing it because it's much easier to see virtually here than in your mind. Where's my cone here? Here's a cone. And everyone see how I get a circle back, cutting it horizontally. All right. All right, this one, next one. All right, let's go back to a cone. Which one of these will I never get as a cross section? Which one will I never get as a cross section? I cut it any way I want. Which one will I never get as a cross section? This one's a little tougher. I'll get 3 of them, but I won't get one of them as a cross section. Not a good day to do it. Not a good day to do it. All right, ready? We're doing a cone, right? Yep. All right, so we definitely know we get a circle. All right, we definitely know we're going to get a circle. So goodbye to that one. All right, let's see what else we get here as I cut it in all different directions. Oh, everyone see, yeah, I get it that figure if I cut it kind of diagonally. So I get that figure. Okay, so now it's down to the square and triangle. Which one will I not get here? Yep, looks like if I cut it vertically, I get a triangle, don't I? So I will never, ever get a square by cutting a cone. All right. All right, little introduction there. Cross sections, faces, edges, vertices. Let's actually start talking about one now. Right now, we're going to start talking about a prism. Okay, a prism. A prism has two bases on it that are always congruent and parallel to each other. All right. The rest of the faces here are usually rectangles. Okay, usually rectangles. Again, the faces are different shapes that are congruent and parallel. And you name a prism by its base. So you see this one right here. How many sides does this base have? If you count it, how many sides does this base have? 5. Remember what we called the 5-sided figure back in the day? That's a pentagon. So I call this a pentagonal. Now you sound boss-like. Pentagonal prism. You name it by its base. All right? You name it by its base. I just wanted to throw this by you because a lot of the problems will do have this term in there. A right prism. Hey, guys, all that means is these are vertical and these are horizontal. That's it. All right. It's not leaning like what's called an oblique. That's all that means is a right prism. It's standing straight up and down. That's what the right prism means. Volume. Now we're going to go fill it up. Okay. We're going to fill it up for volume. How much space is inside? And finally, some good news in this class, maybe not. Can you please go to the very, very back of your packet, the last sheet of your packet? You will be given formulas now. This is called, what you're looking at right now is called your reference sheet. This is what I'll give you on the unit tests in a couple weeks, and the only formulas you'll get on the Regents exam in about 5 weeks. Okay, that's it. Sorry, no distance, midpoint, slope formula. Those are the formulas you'll get, all volume formulas. Can you guys please look at prism? Can you guys look at the volume of a prism? And somebody let me know what your formula sheet says that formula is. Volume of a prism here. Let's keep it going. Volume of a prism. Hayden? Okay, here we go. Let's talk here. Now notice it's capital B and H. All right, let's talk here. Because capital B does not mean base. I think it says it on your formula sheet, doesn't it, what it means? What's capital B stand for? The area of whatever the base is, all right? So please make sure capital B is going to be area of the base, whatever shape it's in. And H is the height of the prism. This might get a little confusing here, so I'm going to slow it down. Let me give you a tip on how to find the height of every prism. Here's the best tip I can give you. It is the edge that connects the bases. You find an edge that connects the two bases, you have found the height. It is the edge that connects the bases. Before we flip it over, can you help me name these 3 prisms below the formula there? Before we move on. This first one here, what type of prism? Rectangular prism, yep. It's always named by the bases. What do you think the next one's going to be called? Triangular. It's named by the triangles are the bases, so I call it triangular prism. And how about this last one? Yep, hexagonal prism. I just want to make sure you guys can identify what the bases are before we find the volume. All right, here we go. Actually, no, we got one more, a special prism. Cylinder. It's a prism. What are the bases? What are the shape of the bases? Circles. So we don't call it you could call it a circular prism, but we refer to it as a cylinder. Please go back to the formula sheet for the volume, because that volume is given to you. We're going to be going back and forth here a lot. Volume of a cylinder. You'll notice it looks very familiar. Hayden, volume of a cylinder. Area of the base times the height. But because you guys can handle it, I want to write a more detailed formula. What shape are the bases again? How do you find the area of one of those circles? Because that's capital B. Pi r squared. So instead of capital B, what can we put in? Pi r squared times the height. Now remember, if you will like that, that's on you, because that won't be on the reference sheet. It's only BH on the reference sheet. All right, let's see what we can do. Let's find the volume of this prism here. First, what type of prism is it? Triangular. All right, so the volume formula, capital B, the area of the base, times the height. Capital B is the area of the base. What shape is the base in again? A triangle. We just finished all this work, didn't we? We just took a darn quiz on it. What's the area of a triangle? 1/2. Okay, everyone look at this right triangle. Can you guys tell me what the base and the height are of this right triangle? It's the two legs, right? Remember, right triangle, base and the height are the two legs. What are they here? 8 and 15. I'm going to stop here. Look, what you just wrote down, that is capital B. That's capital B. The area of that triangle, that's capital B. Now ready for H, the height of the prism. Can you guys find an edge that connects the two triangles? Yeah, you can. It's right here. Here's an edge that connects the two triangles, and that's your height. 8. So does everyone see where big B is? And then the height of the prism. There it is. And when you calculate that, let us know. T, when you're ready. 480, good. And just a quick comment, you guys know I don't care if you have units or not, but if you are a units person, we are now in the volume, not area unit. So it's not squared anymore. Volume is always cubed. Okay? So if you put your units on. And anytime you see something cubed, it's volume. Anytime you see it's cubed, it's volume. All right, one down. Now they get a little bit tougher. Let's go to a rectangular pool. I told you the volume was 1080. And we're given its dimensions are in a ratio of 10 to 4 to 1. Find the length, width, and depth. All right, if you want to draw the pool, go ahead, a rectangular. I'm only drawing it because that's the only thing I can do well artistically. Oh boy, we're getting closer and closer to this region, so it looks like to be about 4 weeks away. We should know that by now. What do we do with numbers in a ratio? Put x's with them, all right? So somewhere on this pool is a 10x, a 4x, and a 1x. All right, since it's rectangular, or it's just a prism, there's my volume formula. Where do you want to substitute the 1080 in for? Where's the 1080 going to go in for here? Jesse? For V, the volume, right? 1080 equals, everyone look at the base. What's the area of the base? 10x times 4x. And then the height of this prism, the edge that connects the bases, is x. I'll help you with the algebra. I'll help you. Maybe you don't need my help. Remember, you're multiplying, not adding. Multiplying, not adding. So let me help you here. 10 times 4 times 1. 40, what do I do with those x's there? X. I got 3 of them. X cubed, 40x cubed. All right, got to get x by itself. What do you think your first move is? Yeah, get the 40 out of there. Divide by 40. And then I think I need to show you something new on your numworks. What's that, 27? Okay. Usually, if that was a squared, everyone like square root, like we do in Pythagorean theorem, I'm good. But it's not a squared, it's a cube. So we can do something similar called the cube root. Okay, we don't want to take the square root because it's not squared. We're going to take what's called the cube root. And let me show you where that is on your numworks. Anybody know where it is? You can steal my fire. Got your toolbox? Everyone's got their toolbox on their numworks calculator? I think it's the second choice. And you can type in whatever number you want there. We want a 3 there. All right, so I go to my toolbox, second one down. I plug in a 3 over here. And then I plug in 27. And there's my value of x. Okay. Make sure we answer the question, though. It said find all the dimensions. And that is just the depth. 3 is just the depth. So plug it back in and find me the width and the length here. All right, after you substituted it in, what'd you end up with here? Juliana, when you're ready.
For width, I got 30.
Yep. Oh, hold on. Width is, go ahead.
I got 30 and 12.
Yep, 30 and 12. The width is the second number here.
Oh.
Yep, that's fine. So it's 12. You got the right numbers. 12, 30. Anything here. You guys are going to see here, it's getting a little tougher. All right, next up, generator. Jed and his generator. I'll let you guys read through here. Okay, the generator can run on 2 hours on a liter of gas. So first thing we need to find is how many liters can it hold. All right, and that is why I've given you this conversion. And if you look at the conversion, everyone see how it's cubed? 1,000 centimeters cubed, that tells me it's volume. It's not an area problem, it's volume if it's cubed. Plus, if you didn't see that, also we're filling it up inside. So anytime we're filling up inside, the space inside a figure, it's going to be volume. First step up, find the volume of the generator. Find the volume of the generator. It's a prism. Use your formula. Area of the base times its height. Okay, first question for somebody. How do you find the area of that base? It's a rectangle. How are you finding the area of that base? Mia, how can I find the area of that base? Yep, 15 times 20. There's capital B. Area of the base, length times width. And then the height is the edge right here that connects those two rectangular bases of 10. So there's my volume. $3,000 cubic centimeters now. Next step, use it to find how many liters are there. If you don't know what to do with the 1,000, do I multiply it with 3,000 or do I divide it? You set up a proportion like I suggested during the area part of this unit. Take the conversion. 1,000 centimeters cubed equals 1 liter over. Keep the same units together. So keep that 3,000 with the 1,000. And again, I don't need to see this if you already know what to do with the 1,000. Go ahead, cross multiply. I'll ask somebody how many liters this generator can hold. Rowan, when you're ready, how many liters? 3 liters. So you ended up dividing by 1,000. And our final step, all right, how many hours will it run then? 2 hours for every liter. And I have 3 liters. So how long is this generator going to run for? Mia, when you're ready. 6. 3 times 2, 6 hours. And guys, that's the expectation here in this second part of the unit, is doing problems like these. I know everybody in here can find just straight up volume. That's not a big deal. Now do something with it. All right, any issues before we go cylinder now? Go cylinder. Okay, I know you guys don't have this problem in your notes anymore because we got rid of it. So let's go right to the thermos. You guys don't have that one, so disregard that. Let's go to the thermos. All right, we got a cylinder now. Same formula. Here we go. Draw yourself a little cylinder. Perfect. We're going to fill it with coffee, but everyone see, we're only going to fill it 1 inch from the top. So it's not going to get filled all the way. We're going to fill it 1 inch from the top there. Put some coffee in. Oh, no. Put some coffee in there. There we go. There's the coffee. "12 inches total height of your cylinder." And remember, we're filling the coffee 1 inch from the top, and it's got a radius of 2.5. How much coffee is in there? Not the volume of the cylinder, how much coffee is in there. First thing, can you guys go back? What's the volume formula for a cylinder? Because look, the coffee takes the shape of the cylinder. So what's your volume formula for a cylinder here? Cylinder. Keating?
Pi r squared times the height.
Yep, pi r squared times the height. We gave you the volume is 2.5. What are we using for the height here? Because it's not 12. That's the volume of the cylinder. We're looking for the volume of the coffee. What do we want to use here instead? T? 11. 1 inch from the top. So this is going to be 11 for the coffee. Good work. And we are rounding to the nearest hundredth now. Hundredth. So once you have hundredth here, hundredth. Mia, what's good?
215.98.
Nice. Nice. And the did you say meters? Inches. All right. All right. Whew. Long day. Anything else? All right, one more cylinder here. I mentioned this earlier. You're going to see, a right circular cylinder. All that means it's standing straight up and down. It's not leaning. All right, that's all that means. It's standing straight up and down. It's what we're used to. All right, what's the deal with this cylinder? Diameter. Oh boy, you're going to have to do something with that. Diameter, 22.5, and a height of 33.5. How many gallons can go in this bad boy? And the conversion they give me is 231 cubic, so I gotta find the volume. Keating already gave it to me last problem, pi r squared times the height. How about the radius here? Radius length? Juliana?
11.
Good, cut it in half. Cut it in half, squared, and then 33.5. Not our final answer though. And I just say that because I don't want you to round this volume. So I'm getting about 13,319 cubic inches. And now we got to convert that into gallons. 231 cubic inches in every gallon. If you don't know what to do with the 231 in your volume, set up a proportion. And that's exactly what I'll do. 231 cubic inches equals 1 gallon. Over. Put your volume cubic inches under 231 and let me know in a minute here to the nearest tenth how many gallons that makes. When you think you have it, let me know. Alex, when you think you have it, how many gallons?
$57.9.
57.9. Are you rounding your volume or are you keeping it all with all the decimals? You should be taking your volume and dividing it by 231 eventually, right? I agree with the 57, it's the 0.9. Sure about it. We got all the numbers. Make sure you are typing every single number in that volume correctly, because that could affect it there. And dividing it by 231. This is a good rounding rule here to make sure you use the entire decimal here. Still getting 57.8 or 9?
57.7.
57.7. There it is. Yep. Every number matters there in the volume. All right, good. All right, a little bit tougher now. 7. First, what type of prism is this? Hexagonal prism. All right. We're going to do baby steps here. I wouldn't have put this on your notes if I didn't think you could handle it. First, what is the volume formula? Just give me the volume formula we're going to use. It's a prism. I don't care what type it is. It's a darn prism. What's the volume formula we're going to use here? Halo, volume formula?
Volume equals area of the base.
All right, we're ready. Can we take care of H first? What's the height of this prism? The edge that connects the two bases there. What's the height, Hayden? Okay, so the H is going to be 8. I'll substitute that in at the end. All right, you ready for capital B now? Capital B is the area of the base. And what shape is the base? Hexagon. So this is going to go back to what you had your quiz on yesterday. I need your help finding the area, of that hexagon right there. Okay, I need your help finding the area of that hexagon. And we're going to have to review some concepts from what you took on the quiz yesterday. 6 inches. Find the volume or find the area of that hexagon. So remember how we're take from the center, you draw 2 radii. You find the area of that one triangle, and we're going to multiply it by 6 of them. That's from yesterday, right? A lot of you guys did very well on that problem, by the way. Very well. Do you want to use 1/2 base times height, or do you want to use 1/2 AB sine C? Look at what I gave you. What do you want to use to find the area of this triangle? Probably what? Base times height, because I already gave you the base. So 1/2 6 times, draw the height in. Let's find the height now. First step, you find the central angle. Find the central angle there for me. $60 degrees. 360 divided by 6, 60. What's the height doing to it? Cutting it in half. So we should have a 30-degree angle right there. And what did that height do to the base? Also cut it in half, so there's 3. So what are you guys going to use? Sine, cosine, or tangent here? Look at what's given. Is this going to be a sine, cosine, or tangent one? What's the 3? Opposite. What's the H? Ooh, that's not. Hypotenuse is across from the right angle. The radii is the hypotenuse. So this is adjacent. So what do we use with opposite and adjacent? Tangent. Tangent of 30 equals 3 over H. How's a 3 radical 3 look? Instead of writing all the decimals, I'll just take the 3 radical 3 your calculator's hopefully giving you. Before we go back to volume, this is just the area of this triangle. I still need to multiply it by how many are there? 6 of them. Yep, to find the hexagon. So times 6. Let's see, that's going to be 3 and 3 is 9. 54. You guys are typing that in your calculator. 54 radical 3 for the area of the hexagon. All right, go back up. 54 radical 3 is the area of the hexagon times 8. Ooh. And final volume, 100th. We're going 100th here. Halo, 100th. Here we go. Ooh, a little tougher one there. All right. And again, sorry guys here, this will be the only day we go all the way here. What I like to do at the end of every class is take the two figures we've talked about and smush them together and say, find the total volume. Okay, find the total volume. This figure here is made up of two figures from today. It's made up of a rectangular prism. And how would you describe that other part on the left? It's not a cylinder, right? It's a what? Like a semi-cylinder, half cylinder. I'll just write half cylinder. Half cylinder. How can you find the volume of the prism? Area of the base. What? You would do length times width, which would be what? 11 times 6. What's the height of that prism? 8. Good. Now let's go to the cylinder. 1/2. What was it? Pi r squared times height from today. All right. Pi. Anybody think they can come up with the radius of that cylinder? Taylor? Where'd you get the 4 from so everyone knows?
The base of the 11
Yep.
minus the
15 minus 11 gives you that part right there, which is the radius. 4, good. And then the height, everybody, be careful here. Find an edge that connects the two half circles. Find an edge that connects those two half circle bases. Anybody know how long that edge is going to be? 6, yep. So that's the height of the cylinder. And before the bell cuts us off, so you guys don't have to keep going, that's 679. Thank you for spending the entire class doing that. That is the last time we do that. I do not like doing that all the time. Have a good day, guys. Yeah.